In this lesson, I'll be showing you how to rationalize surd. What do we mean by rationalization of surd? It simply means the method of moving the root of a surd from the denominator to the numerator of a fraction. For an instance, we're given 3 over root 2. If you observe, the 3 is at the numerator side of this fraction and the root 2 is at the denominator side. So we want to remove this root 2 from the denominator side and want to move it to the numerator side. So to do that, what we need to do is to multiply the numerator and denominator by that root. That means we multiply by root 2. So we have multiply by root 2 all over root 2. I hope you got the idea. Okay. So let's look at example 1. Simplify 3 over root 3. So in order to simplify this, we are given this to simplify. So look at the numerator side, we have 3, but for the denominator side, we have root 3. Since we have root at the denominator side, we want to remove that root and want to shift it to the numerator side. So to do that, we need to multiply both the numerator and denominator by that root. So we are multiplying through by root 3, root 3 all over root 3. So from there now, when we multiply the numerator side, we have 3 times root 3. And that will give us 3 root 3 all over, then root 3 times root 3. That will give us root 9. So next thing to do now, we have 3 root 3 all over 3 because root 9 will give us 3. Square root of 9 is 3. So I want you to observe now. If you observe through now, you see that 3 can go in 3. 3 here, 1. 3 here, 1. So we have 1 times root 3, which will be root 3 at the numerator side, divided by 1 at the denominator side. So we have root 3 as our final answer. Let's look at example 2. Simplify 5 all over 2 root 2. So we have to simplify this. What we need to do is to check through. If you look at the denominator side, we are having roots at the denominator side. So if peradventure we solve a particular question and we arrive at an answer like this where we have a root at the denominator side, we need to rationalize it. So for this case now, we need to rationalize this denominator side so as to move this root 2 to the numerator side. So to do that, I want you to be careful here. We have 2 root 2 here. So we are not going to multiply the numerator and denominator by this 2 root 2. We only pick out the one that has the root, which is this root 2. So multiplying by now, we're going to say multiply by root 2 all over root 2. I hope you can see that. So we didn't multiply through by 2 root 2. So the next thing to do now will be to multiply the numerators 5 times root 2, and that will give us 5 root 2. Then all over, then here now we have root 2 times root 2, that will give us 4. So we have 2 root 4 there. You got that? So next thing will now be, for this our root 4, what's the square root of 4? That is 2. So at the denominator side, we have 2 times 2 at the denominator side. So we have something like this, 5 root 2 all over 2 times 2. I hope you see that. So what's 2 times 2? That will give us 4. So our final answer will be 5 root 2 all over 4. Let's look at example 3. Simplify 13 over 9 root 5. So we're given this to simplify. The first thing you check out is if there is roots at the denominator side. If you look at it now, we have root at the denominator side. That means we can apply rationalization method onto it. So to apply the rationalization method, all we need to do is to multiply the numerator and denominator by that root. And what's the root that we have here? We have root 5 here. So take note, you're not going to multiply with 9 root 5. You're only going to multiply through by the root 5. So we're multiplying numerator denominator by root 5 divided by root 5. So the next thing will be for us to multiply the numerators together. 13 times root 5. So that will give us 13 root 5 all over. Then what is root 5 times root 5? That will give us root 25. So we have 9 root 25 there. So next on line now. So the square root of 25 will give us 5. So for the denominator side we have 9 times 5 there. So we now have 13 root 5 all over 9 times 5. So what is 9 times 5? That will give us 45. So our final answer will be 13 root 5 all over 45. Let's look at example 4. Simplify square root of 2 minus square root of 5 all over square root of 10. If you look at this particular question now, so we have square root of 10 at the denominator side. So is a root of 10. So that means we need to rationalize this particular question. So as to shift this root 10 from the denominator side and move it to the numerator side. So to do that, we are going to multiply the numerator and denominator by this root 10. So multiply by root 10 over root 10. Okay, so multiplying through now, we'll have this root 10 multiplied by this, and we have something like this: root 10 into brackets root 2 minus root 5. Don't be confused here. This bracket means times. So all over root 10 times root 10. So 10 times 10 will give us what? That will give us 100. So we have root 100 there. So the next thing we need to do now is to open this bracket. This root 10 will multiply root 2, and then this root 10 again will also multiply the root 5. So that means we have root 10 times root 2 on the one side, then minus this root 10 will multiply root 5. So root 10 times root 5 all over root 100. So the next thing we need to do now is to combine this together, since we have times in between. Root 10 times root 2, so we can combine this together to form 10 times 2, and that gives 20. So we have root 20 there, minus the same thing we can apply to this, 10 times 5, and that will give us 50. So we can have root 50 there. So all over. So what is our square root of 100? Our square root of 100 is 10. So we have 10 there. Now the next thing to do now is to break up this root of 20. This is a single sort, this root 20 is a single sort, and this root 50 is a single sort. So we need to break it down so that we can have it in the simplest form. So the root of 20 will give us 4 times 5. That's square root of 4 times 5. If you remember, the 4 is a perfect square number. So minus. Then we can break the square root of 50 to square root of 25 times 2, because the 25 is a perfect square number. So we have all over 10. So square root of 4. What is the square root of 4? The square root of 4, if we break this down, we have square root of 4 times square root of 5, And what's the square root of 4? That will give us 2. So we have 2 root 5 there, minus, if we break this down, so we have square root of 25 times square root of 2. So what's the square root of 25? That will give us 5. So we have 5 times root 2. That will give us 5 root 2 there, divided by 10. So I want you to look through. We have root 5 here, and we have root 2 here. Are they similar? They are not similar since they do not have the same root. So root 5 is not the same thing with root 2. They are not similar. So that means this is our final answer.